Just like you can have various wall types, you can also have various curtain wall types. And what we see on the screen are an example of three of the curtain wall types that come just standard inside of Revit. If we select the back curtain wall, which just looks like one curtain wall panel, we can go to Edit Type to see its properties. This curtain wall has a function of being on the exterior of the building. It says that there are currently no curtain panels associated with it. Now that's actually not exactly true. None means that it has the default curtain wall panel associated with it, that there are no vertical or horizontal grids specified, and also there are no mullions associated with it. So basically it's just one big curtain wall panel. But if we click on OK, we can then select on the next curtain wall. Then if we select on Edit Type for that curtain wall, we'll see that it has some properties which are a little bit different. It has the same properties associated with the curtain wall panel. It's just the default. But it does have a vertical grid and horizontal grid layout. And the spacing on that vertical and horizontal grid is 6 foot and 12 foot respectively. That's the reason why it looks like we have some rectangles, if I pull this off the bottom of the screen, where we have them being 6 foot wide and then 12 feet tall. Now, if we want to look at the properties of the next curtain wall, we can do that as well by just clicking on Cancel, selecting on this curtain wall, then coming over here to Edit Type, and from here we can see that there actually is a curtain panel specified for it. So it's a piece of glass that has certain properties associated with it. There's also the vertical grid as well as the horizontal grid, and this is 5 and then 8. And if we take a look at that, I just pull this to the side. This means every 5 foot and then every 8 feet. And unlike the previous two, we also have mullions associated with it. Now, technically, any of these curtain walls could have certain size mullions associated with it as long as there are grids that those mullions could attach to. So in this case, we have the 2.5 by 5.5 inch rectangular mullions associated with this curtain wall type. Now, what I'd like to do is just click on OK, and now make a totally new curtain wall type based off of this back curtain wall panel that we have. And this panel is called Curtain Wall 1. What I'd like to do is select on Edit Type, and now duplicate this curtain wall. And let's just call this Curtain Wall Example Project. And click on OK. For the curtain panel, right now it says none, which once again means it's just the default curtain wall panel. Click there and then click on the little pull-down list. One of the things you'll notice is that we have a wide variety of different kinds of curtain walls that we can pick from. I really shouldn't have said curtain walls. It's not that we have a variety of curtain walls that we can pick from. We have a wide variety of walls and curtain wall panels that we can pick from, such as glazed panels, solid panels. We could put actual curtain walls and have them be embedded into this curtain wall. And we can even embed in just a regular basic wall type directly into a curtain wall. For this example, though, I think that I'll pick one of the curtain wall panels, maybe the system panel solid off of the list. For the vertical grid, let's change that from none to we have one of 4 different options that we can choose from. Either a fixed distance, a fixed number of panels, or some maximum or minimal spacing between the panels. What I'd really like to have in this case will be a fixed distance, so that every 3 feet vertically, we have a new one of these panels. The horizontal grid, I'll change that from none to also be the fixed distance, and I'll make this be 7 feet. For the vertical mullions, obviously these are mullions going in a vertical direction. We'll change this from being none to the rectangular 1.5 by 2.5 rectangular. And now let's use those for each and every one of these mullions that we have left. So for each of these borders where it has the border 1 and border 2, we want to search for that rectangular mullion 1.5 by 2.5. We want to do the same thing with the horizontal mullions. Then when all those are put into place, we'll click on OK. And now watch how this is now automatically updated. So now we have these 3 foot wide panels, which are also 7 feet tall. And you'll notice that we cannot see through them. And that's because unlike the previous 2 panels, which happen to be the default panels, which are made of glass, these panels are solid panels that we actually can't see through. If for some reason we wanted to replace one of these panels with a different panel, we always could, but we need to do that more or less on a one-by-one basis. So what would be required would be we would have to highlight over a panel, hit the Tab key until the panel would highlight, click on the panel, click the little pinhead that's there, come over here, and then select a glazed panel or a wall or whatever kind of panel we'd like to place inside of that area. After doing that, we can click off of it, and now we can see that we have a glazed panel in the location that we had selected. So you can set up any of these curtain wall types so that they have the correct mullions, the correct spacing, and the correct panels associated with them when you first draw them in. And it's also possible, after first creating that curtain wall, to come back in and replace certain panels with other kinds of panels. A curtain grid is not an actual three-dimensional Revit object. Instead, a curtain grid is a line that you draw along your curtain wall panel that will automatically split your curtain wall panel into multiple different segments. So the purpose of the curtain grid is to divide a curtain wall panel into multiple segments. And the line that you see after placing the curtain grid is actually the line that makes up the edge of the curtain panel that you've now divided. In order to place a curtain grid, let's go to an elevation view. Let's double-click on North underneath Elevations in the project browser. Now, technically, we could have placed a curtain grid inside of our 3D view, but I always find it's more accurate to do it inside of an elevation view. Underneath the Architecture tab, we can select on Curtain Grid. Move your cursor down until it's touching the top of the curtain wall. When you do that, you'll get this dashed line that goes straight up and down. Now, this is your actual curtain wall grid line, the dashed line, not the dark line that you'll see after you click. Now, if you move across, when you get to the 8-foot mark, click in order to divide this panel up into two different segments, the one on the left and the one on the right. Now, what I'd like to do is continue to place these curtain wall grids every 8 feet. So at the 8-foot mark, click, and at the next 8-foot mark, click. So once again, we're not actually looking at the curtain grid as we see these dark lines. The dark lines are actually the edges of these glass panels that are inside of our curtain wall. Now, if we take a look on our ribbon, we can see that we have 3 different options when we're placing these curtain wall grids. The first one is called All Segments, which means it'll go across every segment of curtain wall panel that's a part of this curtain wall assembly. If we continue to use the All Segments, one of the things that we can do is come straight down from the top, and then at the 5-foot mark, click in order to break this up into a series of curtain wall panels. So now we have 4 small 5-foot tall curtain wall panels going across this direction, and then 4 15-foot tall curtain wall panels going in this direction. So all segments will span all segments of panels. One segment does exactly what it sounds like. It'll go across one segment of panel. If you select on one segment, move over here to the left-hand side, then at the 4-foot mark, click. It'll now broken up that segment of panel in that one location. Now, these curtain wall panels actually have an interesting property associated with them. And even though we've done one segment, that line is actually going all the way on across our curtain wall assembly. We just can't see it. In order to see that a little bit better, though, we can hit the escape key a couple of times, move up here, and then touch where you have that grid line going across. You'll notice that there's the grid line. It actually is going all the way across your curtain wall panels, but only one spot in one segment has it broken it into multiple different panels. Now, if I'd like to place another one just like this over here on the far panel, what I need to do is click here when we get the dash line, then add remove a segment. Click right in this location, and now it's added a new break or a new segment in our curtain wall panel over here on the side. We can escape a couple of times on the keyboard, and now I'd like to select on curtain grid just one more time. The next option is all except picked. This means that in all locations, except for the spots that we pick, it will break up this curtain wall panels into individual segments. So if we select on all except picked, come over here, right about in this location, right in the middle of all these that we've been placing, click. Now we get this red line going across the top. And now what I'd like to do is place one of these curtain wall segments over on the right-hand side and then on the left-hand side. Because it's in all places except where we pick, that means we need to pick the two segments in the middle. So we can click there, click here. And now once we're done with that, we can actually just hit the escape key on the keyboard. And now in all the locations except for where we picked, we now have a new curtain grid segment. Now if we wanted to move these after the fact, we always could. We can always just move our cursor over to here, click, then either adjust the dimensions or use our move commands and then move them around. But this applies as well if we have mullions already in place. To see that, let's go to our south elevation. So just double click on south underneath elevations in the project browser, zoom in, and right now we can see that we have a wall that has mullions already associated with it. Now, one of the things that you can't do is just move the mullion, because the mullion always attaches itself to that segment. So what we need to do instead is just hit the tab key on the keyboard until we get the dashed line going all the way on across. When we see that dashed line, we know that that's the grid line. We can click, we can then select where we have the little push pin symbol, then select the dimension, and then type in the new dimension that we would like for this entire grid line going across. Click out here after typing in the 5 foot. Notice how the entire thing is now dropped down to that 5-foot mark. And if we wanted to pin it so that it couldn't move again, we can just select on the little pinhead. But one of the things you'll notice is it'll automatically try to jump itself right back up to the spot where it was before. So there's a certain built-in intelligence to this. And what this pinhead is actually indicating is that it should take on the properties of the original curtain wall and the spacing of the original curtain wall. Your best bet is to just clear that out, change this to 5 foot. Don't try to pin it again, because then I'll try to take on the properties of the original curtain wall again. And as long as you don't click on it and intentionally move that grid line, it's not going to go anywhere anyway. And now if we take a look at this in 3D, by selecting on the default 3D view button, we can now see that the curtain wall in the back has those curtain grids that we placed in. In fact, what those actually are, if we zoom in really tight, you notice that looks like there's some thickness, and it is because what we're looking at isn't the actual curtain grid. It's the overall thickness of the panel after it's been split by the curtain grid line. And then here we have the mullions in the correct locations because they adjusted themselves down when the curtain grid line it was attached to was moved down. A curtain wall panel is actually just a Revit family that has certain properties associated with it. To see the properties of the curtain wall panels that we have inside of this view, what I like to do is move my cursor over to the edge of one of our curtain wall panels. Then select the Tab key on the keyboard. Continue to click Tab until one of these panels is highlighted. Then click in order to actually select on the panel. When you go through that process, you'll notice that underneath Properties on the Type Selector list, that you'll get the properties of that curtain panel that you've selected. That'll include the overall width and height of the panel and area of the panel. If you select on Edit Type, you'll then get to see the properties that make up that panel. For this kind of panel, we can see that it has a material, which is glass, and it's currently offset 1¼ inches from inside of the curtain wall. This is the location as far as how it's centered inside of the curtain wall assembly. The thickness of the curtain wall panel is 1 inch. If we wanted the panel to be thinner or thicker, this is where we could adjust to that. And if we wanted to create our own curtain wall panels, we could do that right now by coming up here to the Duplicate tab and give it a name that's appropriate for the kind of panel that you're creating. In this case, I'm just going to call it a solid fill panel and click on OK. Next thing is we can adjust the offset value. Now, I actually like where these curtain wall panels are currently located inside of the curtain wall. If I didn't, I would adjust its offset value now. For the material, instead of glass, let's pick a different material off of our list. So where we had glass, there's this little button that'll show up over here. You can click on that little button to open up the material browser. And from here, I don't really care which material that you pick off of the list. Just look through the list, find a material that you think might be interesting on the inside of the curtain wall, and then pick it. For my example, I'm going to pick something ridiculous, just to show that I can. And I'm going to pick parking stripe off of the list. Come down here to OK. For the overall thickness of the panel, this is where it can be adjusted. And instead of 1 inch, I think I'm just going to make it 3/4 of an inch in thickness. Now I'll click on OK. Now we can see that that panel has changed to that parking stripe panel. And if I click off of it and then zoom in, we can see it's kind of a yellow color. In fact, if it was rendered, it would be a really bright yellow color. So now we have a panel that has those properties associated with it. If we wanted to change more panels, we could do the same thing. Come over here, hit the tab key until the panel is selected, click on the panel, then on the type selector list, because we've already created that panel, it will now show up on the list. Select the solid fill panel, and now we'll have a panel with those properties associated with it. So your curtain wall panels are just three-dimensional Revit families that have a certain thickness, offset value, and material associated with them. A mullion is actually just a two-dimensional shape, which is extruded down the length of the curtain wall panel. To see this two-dimensional shape, let's zoom into one of our existing curtain walls. Just spin the wheel of your mouse to zoom in, and then you'll find a rectangular shape out at the end of the mullion. Then the overall length of the mullion is whatever the length of that curtain wall panel is, or in this case, the entire length of the curtain wall itself. Now, the dimensions that control this rectangular shape can be found underneath the properties of the mullion itself. So if we select on mullion from underneath the Architecture tab, and then click on Edit Type, we'll find the properties of whatever mullion we currently have selected. In this case, it's a circular mullion, and the properties of the circular mullion is that it's 2.5 inches circular. We can find those dimensions if we scroll down toward the bottom of the type properties for this mullion, and we can see that it has a radius of 1.25 inches. Now the diameter is always double the radius, so double the 1.25 inches is 2.5 inches circular. Now select on the rectangular mullion, we can see that this is a mullion that's 1 inch square. The width on side 1 and side 2 is 1/2 inch and 1/2 inch. Add those up, and that's 1 inch. The overall thickness, which is the other direction, is also 1 inch. We could come over here, and if we wanted to create just a typical rectangular mullion, but a fairly large rectangular mullion, maybe 5 inches by 5 inches, we could do that by selecting on the Duplicate button. After clicking on Duplicate, I'd like to make this be 5-inch square. Click on OK. Here we can see that we have a profile shape, and it's the System Mullion Profile Rectangular. By the way, anytime you see the word system, it means you can't actually edit that profile shape. It's just something that comes with Revit, and it happens to be rectangular. The overall dimensions of it, though, can be controlled. In this case, the thickness, which would be 5 inches, the width on side 2, this is going to be 2.5 inches. Then the width on side 1, also 2.5 inches. If I click on OK to that, we now have a rectangular mullion which is 5-inch square. Now one thing I'll point out is that we had the side 1 and the side 2, but that really indicated is either side going right down the middle of the mullion. In the instance of this mullion that we're looking at right now, if this had been 1.25 inches from the middle to this direction, and then 1.25 inches from the middle to this direction, the overall dimension of that would have been 2.5 inches across. Now, if we wanted to replace the existing mullions inside of this curtain wall with the mullions that we just created, we could do that. We have the rectangular 5-inch square. And what I'd like to do now is just hit Escape a couple of times, select on the curtain wall, come in here to Edit Type, then look for what kind of mullion is currently being used with this curtain wall. I can see we have vertical mullions and horizontal mullions. I don't really want to change the interior mullions, but I wouldn't mind changing the exterior or the border mullions. So let's change the 2.5 by 5 rectangular to be that rectangular mullion 5-inch square. Do that same thing again. Come down here, 5-inch square. Do the same thing for the horizontal mullions. Then once they're replaced, click on Apply. You'll notice that they've now increased in thickness by 2.5 inches because that's the properties of this mullion. It's twice the size of the original mullion. If we click on OK to that, then click here, you'll notice this is the original size of that mullion, and then we replaced all the mullions going all the way around the perimeter with a thicker mullion, which is 5 by 5. And now you can see that we have that 5x5 mullion going all the way around the perimeter. One other thing that I'll mention is if we wanted to create our own custom mullion shapes, we could do that as well. And I'll just show you the process of creating that shape. We won't actually load that into the project just yet. If we come up here to the big R, which is the Applications menu, we can highlight on New and create a new family. If you scroll down, you can find your profile shapes. When you find Profile Mullion, click on Open. And what you need to do is draw in your mullion right in this area, realizing the interior side is over here, the exterior side is over here. And the center of the mullion should be where these two lines cross each other. So if you wanted to draw in really any kind of shape, you could just use your line work tools, draw in the exact mullion shape that you would like, save it, give it a name, then load it into your project. After you've done that, just click on the X. What you'd be able to do is to come up here to your mullions, select on Edit Type, pick one of these families off of the list. You could duplicate it, give it an appropriate name, and then where you have the profile shape, pick your custom profile. In this case, an example of that would be the C channel profile off of the list. And then you'll have that new profile shape as part of this kind of mullion family. Click on OK, assign it to the curtain wall, and then whatever shape it is that you've drawn will now be part of your curtain wall assembly. You'll find that when you start to make corners with your curtain walls, if you zoom into those areas, that your curtain walls don't actually clean up correctly at the corners. Oftentimes you'll have conditions like this where your two mullions will hit each other and not actually form into one mullion. In fact, if we would zoom out, we can see over here on the other corner that we have still a different kind of corner condition that's just not cleaning up correctly. So we actually have a couple of different ways that we can clean up these corner conditions. The first way is if we go into a 3D view and take a look at it. Now, if we zoom in here to the corner, one of the things that I'd like to do is just put my cursor over one of our existing mullions, and then hit Tab until that mullion highlights. Click where the mullion highlights, then click the little pinhead. This will allow you to actually manipulate that mullion. After it's been highlighted, right-click and then select the mullions along the grid line. This will select all the mullions that are along the same grid line as this mullion is. Once that's occurred, if we zoom out, we'll see that the one mullion has been unpinned, but the other two mullions are still pinned. What we need to do now is to unpin each of these mullions. And we can either do that by just clicking on each of the pin heads or by selecting on Unpin. If you click on Unpin, they'll all unpin. And now what we need to do is delete those mullions along that end. If you click the Delete key, we'll remove the mullion. Now we'll still have the mullion that was attached to the other curtain wall. And what we want to do now is replace this mullion with a more appropriate mullion. To accomplish that, do the same process. Hit the Tab key until the mullion is selected. Click on the mullion. Now we can either unpin it or just right-click, select mullions along the grid line. Now we'll have selected all those mullions along the same grid line. Come up here to Unpin. And then underneath Properties, click where we have our mullion on the Type Selector list. And now select this Quad Corner Mullion. Actually, the important thing to know is that you're selecting on a corner mullion, whether it's an L shape, the quad corner, or even this V corner mullion. One way or another, you'll need to select on a corner mullion because this is a corner mullion condition. Select the 5x5 quad corner, and when you do that, it'll automatically clean up with the other wall. Now, if we want that to clean up all the way across, we can do that as well. So instead of picking these on an individual basis, we can have it clean up all the way around. If we select on one of the curtain walls, we can then come over here to Edit Type. Then where we have our vertical grids, the next thing we need to do with the vertical mullions is to change those from being a rectangular mullion, 5x5 rectangular, to being that same quad mullion. So if we come up here on the list, find the quad corner mullion, and then do the same thing again with the border 2, change that to be the quad corner mullion, we can now click OK. Now it's going to give us an error message. Really what it is even though it's an error message, it's just giving us a warning saying, if you do this, some mullions will get deleted. And that's okay because we want to delete them in order to replace them with the correct mullion conditions. So if you select on delete elements, it'll then go through the process of cleaning it up correctly. If we zoom in, you can see that, in fact, this has come to the proper corner. If we zoom back out and then zoom in over here, we'll find that it's even made the turn correctly from here over to here. So there's two different ways you can clean up your corner mullion conditions. Either do it individually by tabbing through, selecting on the mullions you want to replace, and then picking the correct mullions off of the type selector list, or by building those mullions directly into the actual curtain wall family itself. After that kind of mullion's been established as being the corner mullion, it will automatically clean up in all the different locations where two different curtain walls attach. Like Revit's walls, Revit's floors are made up of multiple layers of material, and we can find these floors if we go to the Architecture tab and then select on Floor. Underneath Properties on the Type Selector list, we can find a variety of different types of floors available to us. That includes wood joist 10-inch ceramic tile, 10-inch wood finish, and then the joist 12-inch carpet finish. These are examples of combined floors. And when I say combined floors, I mean that the structural elements as well as the finish elements of these floors have been combined into one type of floor. Now, I'm not actually a big believer in this type of floor system. I like to have two separate floors, one which is a structural floor, and then another which is a finished floor. The advantage to having two separate floors, one which is the structure and the other which is the finish, is that first, that's how it's originally constructed out in the field. The structural part of the floor is put in first, then they come in later and add in the finished materials such as carpeting and tile over the top of the structural floor. In a Revit world, there is an extra advantage to it as well. This means that you can model the flooring materials correctly at the right elevation inside of the right rooms without needing to worry about how those flooring materials can clean up with the interior and exterior walls. It also means that if you make a modification to that flooring material in one part of the building, you won't need to automatically replace the floor in other parts of the building, should that big long floor span through multiple different rooms. All you need to do is adjust the flooring materials inside of one space, and then just those materials, that floor, will update in that one area. So what I'd like to do is come in and create a new structural floor, and then we can have some separate finished floors that we can create later. To create the structural floor, what I'd like to do is select on one of the existing floors that's already pretty similar to the kind of floor that I'd like to have. In this case, the wood joist 10-inch ceramic tile should work just fine for us. So let's select on the wood joist 10-inch ceramic tile, click on Edit Type. Now let's duplicate this floor and get rid of the ceramic tile too. I just want to have the wood joist 10-inch available to us. Click on OK. Next to structure, click on Edit. From here we can see all the different layers of material that make up this floor. What I like to do is just have the structural part of the floor in place. So we can get rid of this tile mosaic gray as well as this concrete cast in place because we don't need it. That'll be part of the other flooring material that will be placed on top of this structural floor. Then we also need to consider, do we want to keep the plywood sheathing? For this example, let's go ahead and keep the plywood sheeting because no matter what our material is up above, that plywood sheeting still needs to be in place so that we can put that tile or that carpet or whatever on top of our structural floor. So to get rid of these extra materials, we just select on the number 1 and then click on Delete. With the number 1 highlighted again, click on Delete. Now if we take a look at our total assembled floor, we can see that its total thickness is 10 inches, which happens to actually for once correspond with the name of the wood joist 10-inch type here. And if we would click on OK to that, we can now see that we have a new floor type, which is called wood joist 10-inch. Now if we wanted to add or subtract materials, we could always come back in here and do that again. Come in here to Edit, and then either insert in another layer of material or delete out a layer of material. We also could pick whatever materials that we wanted off of the materials here and adjust the thicknesses from right here. Now I'm going to click on OK because this is the way that I want my floor to be. If I click on OK one more time, we can now see that here on the type selector list, we have this wood joist 10-inch, which can now be used as a structural floor, and then it would be drawn in at the normal floor level. Any of the finished materials would then be drawn in over the top of this structural floor. There are two ways that I know of to put floor finishes inside of a Revit model. One way is to have those materials already assigned to a Revit floor. Then all you need to do is put that finished layer of material right over the top of your structural floor. Then you're basically done. But the only other thing you may need to do is at that time would be to either put a note indicating that that happens to be whatever floor finish it is, or maybe just a little tag that says this floor has this floor finish. The other possibility is instead of putting that finished floor down, is just to have a hatch pattern, or in Revit terminology, a fill pattern, placed over the top of the floor that happens to have the right symbology associated with that kind of flooring material. Different people believe in different ways of handling that, and neither one of those solutions is necessarily wrong. But in this example, what we'll do is have that finished floor sitting on top of the structural floor and use that as our solution. In order to accomplish that, we need to draw a floor in over the top of this floor. Let's go to a floor plan view, in this case, the level 1 floor plan view. Zoom into the floor area, come here to Architecture tab, and then select on Floor. Now, unfortunately, we currently don't have any finished floors available to us here underneath the type selector list, so we'll need to create one. So if we click here on the type selector list, I'd like to have a ceramic tile floor. So we'll click where it has ceramic tile, click on Edit Type, and now make a duplicate of this floor. And what we'll do is get rid of the structural part of the floor and just keep the ceramic tile portion of it. Now let's rename this floor, instead of being wood joist 10-inch, to be Finish Dash Ceramic Tile. Then click on OK. Now for the structure, where we have Edit, click on Edit. And the first thing I like to do is move both of these floor finishes in between our core boundaries, because Revit actually won't allow us to get rid of all the materials between our core boundaries. There always needs to be some materials between those core boundaries. Select where we have our finishes and then move down. Select the finish, move it down. Now we can delete the structural parts. So select on the structure one, hit delete. On the next one, delete. Now we have a finished ceramic tile, the grand total of 3/4 of an inch in thickness, and we can click on OK. Now remember, this is 3/4 of an inch thickness, and that's important. So let's click on OK. And now let's start the process of drawing in this finished ceramic tile floor. But for the offset value, it needs to be 3/4 of an inch so that it can sit on top of that structural floor. The next thing we need to do is come up here to the rectangle tool, click the intersection of these two lines, come straight over, click the intersection of these two lines. Now we can either lock these in place or just leave it as it is. And for this example, I'll leave it as it is because that means that if we ever need to adjust just the finish as opposed to the structural part of the floor, we can adjust that separately from the structural parts of the floor. Now, if we click on the big green check mark to finish that off, we now have that finished floor in place. Now, if we had materials assigned to that finished floor, we would see that floor pattern here inside the view. What I'd like to do now is take a look at this section and make sure that it's at the right elevation. So if we select on the section mark, right click, and then click on Go to View, we can now zoom in to see if we have that floor material here in place. Now if I select right here, it looks like I have this finished ceramic tile floor, and for whatever reason, it looks like it dropped in just a little bit too low. It didn't pick up that offset value that I originally put in there. So for this height offset from level, let's adjust this and make it be 3/4 of an inch, and then click on Apply. See how it raised it up? And now if we take a look at this back in the plan view by just clicking on the X, we're still not seeing any sort of tile pattern, which means that the material must not have a pattern associated with the surface of it, but we now have that flooring in place. Now, if we did want to see that tile material, the next thing that we could do is actually edit the material of that floor. So I'm going to click on the ceramic tile floor, come over here to edit type, come over here to edit next to structure. Now I can see that there's a finished material, which is the tile mosaic gray. I'll click there, then click the little button next to it. I'll notice that there's no surface pattern currently associated with this tile mosaic gray. That's the reason why we're not actually seeing it there. So the next thing that we should do is try to find a pattern that can be used for that kind of tile. So I've selected on model for the type of pattern, and I want to use an 8-inch tile. I'll click on OK to that, click on OK, click on OK one more time, OK again. Now we can see that we have that tile pattern associated with that finished floor. The way that I prefer to place the materials on the floor surfaces is to actually create a finished floor layer and then associate material to it. If you know that you're going to be having lots of different sorts of floor patterns, then instead of assigning the material a pattern like we just did, then your best bet is probably to put that finished material in just like we did before, but then use a custom hatch pattern or a fill pattern right over the top of your Revit floor in floor plan view so that you can see the material, but not necessarily assign that material directly to the materials to make up your finished floor layer. In this view, we have two floors with a section cut through both floors. On the left-hand side, if we zoom in, we'll see a floor that slopes the entire floor. That includes the top of the floor as well as the bottom of the floor. And an example of this kind of floor structure would be a parking garage ramp. If we would zoom out and then zoom into the floor on the right-hand side, we'll find that the structural member down at the bottom of this floor goes straight all the way on across. And then it's the material up above where the structure is at that slopes from this point down to this point. A good example of this kind of floor would be a typical concrete floor in a building that's sloping down to a drain. Now, the difference between these two floors is actually just one check mark in the properties of a floor type. Now, to find where that check mark is located at, we can select on the floor on the left, then click on Edit Type. Select Edit next to the word Structure, and from here we can see that underneath the variable that currently neither one of these layers of material have a check mark next to variable, which means that their thickness cannot vary. So it always needs to be 4 inches thick concrete lightweight, and it always needs to be an 1/8 inch thick metal deck. Since that can't change, it means the entire floor needs to slope whenever a floor is told to slope in a certain direction. But if we click on OK and OK again, click on the other floor, select Edit Type, Edit Next to Structure, we'll find that there is a variable thickness check mark next to concrete lightweight in this floor type. The metal deck is still not a variable thickness, so it always needs to be 1/8 of an inch thick, but the concrete lightweight can vary, so it could be less than 4 inches or it could be more than 4 inches if required. And that's what we're looking at here on the floor over on the right-hand side. It's going from 4 inches down to 3 inches. So whenever you're setting up your floors inside of your project or inside of your Revit template, you always need to consider what will this floor be used for. If it's the kind of construction that means that the entire floor needs to slope, then you do not want to have a variable thickness for it. But if it's the type of construction where just the top layers of material need to slope, that's where you need to put a check mark next to variable thickness in that floor type. There are three main types of stairs in Revit. One is a precast, the second is a cast in place, and the third is an assembled stair. Let's first look at a precast stair. Zoom into the staircase over on the left-hand side by just spinning the wheel of your mouse. But the precast stair, if we select on it, we can come up to Edit Type underneath Properties to see the type properties of the staircase. For this precast stair, we have options to set the overall maximum riser height, the depth of the tread. The run type contains the shape of the tread. Should it be rounded off or does it come to a point? There's also information related to the thickness of the landing itself, as well as what kind of connection is associated with this precast stair. As we can see here, we have a notch which is 4 inches by 4 inches at the end of the staircase, and it notches into the landing up above. If you wanted to change the gap, in this case 3/8 of an inch, between the staircase and the landing, we could do that from here. As far as adjusting the overall properties of the notch, we could change that from here as well. If we wanted to change this notch extension to be 6 inches instead of 4 inches, we could change it here, select on apply, and you'll notice that the extension gets longer here inside of our section view. If we wanted the notch to be a little bit thinner, maybe 3 inches instead of 4 inches, click on apply, and then we'll see that adjustment be made. For this staircase though, I'd like to bring it back to the 4 inches and 4 inches that it was before, and select on apply to readjust it back to its previous state. Also, where we have the run type, I mentioned before that this is what controls the overall shape of the nosing here on the treads. Well, if we select where it has 3/4 inch nosing, 6.5 inch depth, and then select on the little button to the right of it, we can find some of the hidden properties that make up this kind of staircase. We can see that the underneath side of the staircase is supposed to be smooth, and as opposed to seeing it step up on the underneath side of the staircase. To see that, if we select where it has smooth, we can click, change that to stepped, and then click on apply, and now we can see how it steps itself down. Let's change that back by coming back to stepped and change it to smooth, select on apply. Then you have the structural depth, which is 6.5 inches from here to here. That's how deep the overall structure will always be. We then have the material for the staircase, as well as the nosing profile, what's that shape on the end of the staircase, and a few of the properties associated with the stair. Now, if we select on OK, there's also options related to the landing. So if we select where it has an 8-inch thickness, click on the little button next to it. From here, we can see the materials that make up our landing, as well as the overall thickness of the landing. And if we include a checkbox next to Same as Run, we can then assign properties to it for any tread or nosing length information, which may be associated with the ends of our landing. Now I'll just leave all this information the same by clicking on OK. Click on OK. Now let's take a look at our next staircase by zooming out and then zooming in to our cast-in-place staircase. A cast-in-place is usually a staircase which is poured on site, so one concrete pour. That's the reason why we're not seeing a notch here on the end. Now if we select on the staircase, we can come over here to Edit Type, and we'll notice that we have the same riser height and tread depth options that we had before on the other staircase. But one of the options that we don't have is for that notch, and that's because the monolithic stair does not have that notch property associated with it. It also has the same kind of properties related to the run type, which is the nosing information, as well as the landing information. All that can be adjusted here inside of the monolithic stair. I'll click on OK to that, zoom out, and then zoom over to the right-hand stair, which is an assembled staircase. Now this is the kind of staircase that would typically be assembled on site. It's usually made out of either steel or wood or some material along those lines. Typically not a concrete stair, though it may have concrete pour for the top of the treads as well as the landing. Now if I wanted to make a change to the stair, I could select on the staircase and come over here to Edit Type. Here underneath Edit Type, we can see that we have the same kinds of properties that we had before. But we'll also notice that for the supports, instead of none, we now have options for strainers. And from here, we can either have a closed strainer or a carriage or an open strainer, or we can specify that we don't want to have a strainer at all. There's also options here for the right support type and left support type. Well, if we click where we have that kind of strainer, there'll be a little box over to the right-hand side. If we select there, this is where we have the materials for our strainer, as well as the section profiles for the strainer. Now, an example of what you might do with a section profile would be, instead of having a rectangular shape on the underneath side of your staircase, perhaps you wanted to have a strainer that was a C shape, metal channel. To do that, we could come down here to where it has default, click, and then pick any profile shape that we want to create. In this case, the C channel profile, and then assign that to the staircase. So if you just click on apply, we now have that C shape associated with the staircase. One other thing I'd like to do, I know that the C channel is flipped the wrong direction. So if you put a check mark here, it'll flip it so that it's not facing in. It'll be facing out, so we'll be able to see the C shape when we look at it in a 3D view. I click on OK to that, then click on OK one more time. Now let's take a look at our staircases in a 3D view. So come up here and select on the default 3D view button. As we can see, we have the precast stair, the cast in place stair, and then the stair that we just made a property change to. This is that C channel. It's called a C channel because it looks like the letter C as far as its shape is concerned. And this is an assembled staircase. In Revit, you have 3 different kinds of staircases, and they each have their own sets of properties associated with them. The precast stair, which is the only one that gives you the option for a notch. The cast in place stair, which is very similar to the precast, except it doesn't have that notch option. And then the assembled stair, which is your typical wood or steel stairs, the kind that you see in most buildings. To create a custom staircase, I usually like to begin by drawing in the basic body of the staircase, then come back in and modify that staircase. To achieve that, we can go to the project browser and then underneath floor plans, go to our level 1 view, then zoom into our staircase. Now, what I like to do is flare out the bottom of the staircase, as well as round off the end of the landing. To accomplish that, we need to first select on the staircase itself by moving the cursor over to one of the treads and then clicking on the tread. That'll highlight the entire staircase and allow us to select on Edit Stairs up on the ribbon. After clicking on Edit Stairs, let's go through the process of modifying the bottom tread of this part of the staircase. So select on this part of the stair, then come up here and select on a button called Convert. Now it will pop up this dialog box, and all that it's saying is that if you do this process, this will no longer be a stair component. Instead, it'll be a sketch-based staircase, which means that if you need to make any modifications, you'll have to sketch it in from here on out. And that's okay, that's what we want to do. So click on Close, then select on Edit Sketch. Now what we need to do is modify this bottom tread of the staircase. I'd like to have it flare out in this direction and then flare out in this direction. To accomplish that, I'll come up here to where we have Boundary and select on Boundary. Then select on the Start End Radius Arc. Pick this point, come out here at about a 45-degree angle, and then click, and then make a rounded arc in this direction like that. Then select on the Line tool, and then come out about 3 inches to your left. Now the next thing I'd like to do is just hit Escape a couple of times to get out of drawing lines. Then pick on this green line, click and hold your mouse button down on the dot, and then pull that dot back to the end point of this arc. Now I'd like to duplicate the same information over to the other side of the stair. To accomplish that, I can either draw it again, or I can just window around those objects. Then come up and use the Mirror command. So if you select Mirror Pick Axis, you can then pick on this blue line to mirror it around to the other side. The next step will be to get rid of this dark line here. This is actually a riser, and ultimately I'd like to place that riser from this point down to this point. So with the riser highlighted, click the Delete key on the keyboard, then come up here and select on Riser. Make sure that line is selected, click the endpoint here, come down like this, click the endpoint down there. Escape a couple times on the keyboard. Finally, we need to adjust this green line by selecting on the line, clicking on the dots, and then pulling it back to the same location as the other line. Now that I've created this flare out condition here at the bottom, click on the big green check mark. What it's telling us is that we have an invalid path for the staircase. This is a fairly common error. And what this means is that this line here is not extended all the way out to this final line that makes up the staircase. So we'll select and continue, click on the line, drag that line out to the end, then click on the big green check mark again. Click the big green check mark one more time, and now let's take a look at our staircase in a 3D view. So move your cursor up here to the default 3D view icon, and let's take a look at the staircase. What I'd like to do is click on this corner of the view cube to spin the staircase around. Now, if we zoom in, we can see that we have the railing coming around, sort of wrapping around the edge. And here we have that same stair condition that we just drew in and planned here. Now, I'd like to do something similar with our landing between our 2 sections of stair. So let's go back to a plan view, go to level 1, zoom out, select on the stair, click on Edit Stairs, click on the landing, and once again, we need to convert this landing so that it's a sketch object. Click on Close, then Edit Sketch. Now let's delete this green line here, as well as the green line here. Now what I'd like to do is have an arc from this point down to this point, and then a second arc from this point to this point. So select on the start end radius arc, click the endpoint here, come down, come out 3 foot 6 inches, and then click, and then draw in another arc from this point straight down. And in this case, I don't want to bring it all the way out to that 6 inches. I just want to bring it out to right about here. Then click on the big green check mark. After doing that, if we zoom out, we can see that we have a nice round back to the landing, a much smaller curve between this stair and this stair, and we still have the custom shape down at the bottom of our staircase. Click on the big green check mark to finish off the stair. We'll notice that the railing here is also adjusted to meet that curve. And if we select on the default 3D view icon, we can now see our custom staircase with all of its curves. When you first draw your staircase, there's a very good chance it'll come in with a railing already associated with it. But if you wanted to modify the path of that railing, you would need to modify it after the stairs have been drawn. The first thing that you could do is go to a floor plan view, such as your level 1 floor plan view. So underneath the project browser, go to Floor Plans Level 1 and double-click. Then zoom in to your staircase. From here, we can make modifications to the path of the railing. So if we select on the individual railing, then click on Edit Path, we can then move each of these lines that are associated with that railing. For instance, I can select on this railing here, click here, come up here to move, pick a base point, and then move it whatever distance I'd like to move it. In this case, I'll move it 6 inches in. Click on the big green check mark, and now the railing is 6 inches in from its original location. We could do the same thing on the other side. Select on the rail, click on Edit Path, pick each of these lines by holding down the Control key on the keyboard, and then selecting on each of the lines. Come up here to move, pick a base point, come up 6 inches, hit Enter, click on the big green check mark, and now if we take a look at it in a 3D view by selecting on the default 3D view button, we can now see that those rails are now in 6 inches from their original location. We even could have made modifications to the railing path, meaning whether or not it's a straight line or an arc or whatever shape we'd like the path to be inside of that same location. So here in the project browser, if we go to the level 1 again, select on one of the rails, we can click on Edit Path, and we could select the start end radius arc, click here, click out here somewhere, draw just this little radius off here on the end, click on the big green check mark, and now we'll see that the railing comes down here, and it has this arc that comes around. You can do something similar over here on the other end, selecting the railing, come up here to Edit Path, click on Line, click here, and now I'd just like to add this end extension, which comes out 1 foot 6 inches in this direction. I'll hit Escape to get out of the drawing of the line. Come over here, click the endpoint. Come over here, 1 foot 6. Click on the big green check mark. Now if we take a look at our railing from here, we can come back up here to the default 3D view icon. Spin this around by holding down the Shift key on the keyboard as well as the wheel of the mouse, or by just selecting on a corner of the view cube. Here we can see that it has that arc now down at the bottom of the railing, as well as that extension on each end of our railing. But another thing that we could do is add another railing to the staircase. To accomplish that, what we need to do is once again go to a floor plan view. Then here underneath the Architecture tab, select on railing. Then this is the most important part. We need to pick a host for this railing. So select on Pick New Host, pick that staircase, and now let's draw a railing straight up the center. So click here at the end of the stairs, come up here, click at this point, come over here, click, come up here, then click. Now the important part to drawing these railings in is that if you want it to slope, it needs to be its own segment. If you'd like it to be straight, it needs to be its own segment. If this had all been one line, then it would have forced this railing to all slope up from this point all the way up to this point, which would have forced the railing to become disconnected from the staircase, which is something that we don't want. Individual segments, segments for straight sections, segments for the sloping sections. They come up here to the big green check mark to finish off the railing. Now, if we take a look at it in 3D by selecting on the default 3D view button, we can now see that we have this new railing going right up the center of the stairs. It's sloping up in the spots where we had the sloping up, and it's going straight across in the areas where it's supposed to be going straight across. In this case, on the landing.